In this video, we're going to talk about how to use the general solution of a cosine equation to solve a more complicated cosine equation, one that has a different sinusoidal axis, amplitude, period, and phase displacement like the one up here. So in this particular equation, notice that the sinusoidal axis is 2, so this line right here, 2, would cut the graph in half vertically. It has an amplitude of 3, so it means we're going up 3 and down 3 from the sinusoidal axis, so it has a height of 5, high point at 5 and a low point at -1. Pi over 8, just to remind you, is my b value, so the period is 2 pi divided by pi over 8, or 2 pi times 8 over pi, which ends up being 16. So this has a period of 16, and if you notice, if we go from high point at 2 to the next high point at 18, that it does have a period of 16. From 2 to 18 is one period here. Okay, so this is the period, equals 16. You'll also notice that if you went from one of these marked values where y equals 1 to the next marked value, that would also be 16. Or if I go -2.87 minus 16, I get to -18.87. So this has a period of 16. You'll also notice the phase displacement of -2, which means the high point, instead of being at 0, has shifted over to +2. So we have it that it shifts right 2. So that's what the phase displacement does. So when you notice now, if I were to solve this equation, I'm trying to solve this equation for the places where f of x equals 1. In other words, y equals 1. You'll notice right here, this is where y equals 1, and there is a line, it's kind of light on your notes, that connects all these points, and you can see that the coordinates of all these marked points have a y coordinate of 1, and the x coordinates are various x coordinates. You might also notice that these x coordinates are no longer opposites of each other. So the solutions here are not opposites of each other like they were when we just looked at plain old cosine. These are solutions, are all the marked solutions between -20 and 20 on the x-axis, where y is equal to 1. Now, how do we get these solutions? I want you to notice a couple things. I want you to notice, first of all, that these solutions, even though they aren't opposites of each other, they do have symmetry. If I started at 2 and went over to 6.87, I'd be adding 4.87 here. If I were moving from +2 to -2.87, that would be -4.87. So there is still symmetry. It's just not symmetry centered around the y-axis anymore. You'll also notice that the distance between points that are exactly a period apart, for example, these 2 points, the distance is 16. If we go from one point to the other, I guess I should probably have gone from right to left, left to right. If I go from left to right and add this, that there's 16 from here to here. There's also 16 if I go from here to here, is also 16. Okay, so I'm adding 16 to get from one point to another. -2.87 to +13.13 is 16 as well. It's also 16 from 6.87 to -9.13. So we're adding a period, it's just the period is no longer 2 pi. So I can show you these things from having solved the equation already. I can show you this pattern, but how would you actually start with an unsolved equation and get to this? So let's start by substituting 1 for f of x. So we're saying 1, I want to know when this equation equals 1, what x values will cause this equation to equal 1. And before we go any farther, I might want to comment to you that why the point of doing this is because when that sinusoidal functions are used to represent lots of things in the real world, like average temperature, like the fox population problem, like tides coming in and out. You saw quite a few different examples, radio waves. And remember, on the fox population, one thing you were trying to find is when the fox population dipped below 300, and you were trying to figure out when y was equal to 300, what the x values were, so that you know between which years the fox population was endangered. With the tide problem, you were trying to find two x values, or 2 times in that case, where the tide was above 11 feet, so that boats could go in and out of this harbor, this inlet. And so you were looking at 2 places on the graph where the y value was 11, and you're trying to figure out those x values. Now that we have this method of solving, we'll be able to solve for those problems directly without just tracing and guessing and checking on the graph. So let's go ahead and start solving this. The equation is 1 equals 2 plus 3 cosine pi over 8 times x minus 2. The first thing we're going to do is subtract 2 from both sides. That would give me negative 1 is equal to 3 cosine pi over 8 times x minus 2. The next thing we're going to do is divide by 3. So we have negative 1/3 is equal to cosine pi over 8 times x minus 2. Now for those of you who may be slightly algebra challenged, do not attempt to do any of these numbers inside the cosine function until you have dealt with cosine. You have to work from the outside in when you're solving an equation. So the next thing I have to do is deal with cosine. How do I undo cosine? Using inverse cosine. So my next step would be saying inverse cosine of negative 1/3 is equal to all of this stuff that is inside the cosine function, pi over 8 times x minus 2. Now this is very, very important at this point. Red flag this. At this stage of the game, when you see inverse cosine of something, you have to stop and write the general solution for inverse cosine. If you keep solving for x right now, you will only get one correct solution, and all the other solutions will be incorrect. So you need to stop and write the general solution and then continue solving for x. So in other words, I'm going to replace inverse cosine of negative 1/3 with plus or minus inverse cosine of negative 1/3 plus 2 pi n. So what is inverse cosine of negative 1/3? Let me find that on the calculator. So I'm going to open another window here and find inverse cosine of negative 1/3. Okay, it's 1.91063. Now, I'm going to need to do some more with this in just a minute, but we're just going to go ahead and write that one down for right now. 1.91063. So I'm going to need to know plus or minus that and plus 2 pi n. So when I go back to my equation now, I'm going to write this as 1.9106, I think I'll stop there, plus 2 pi n, and negative 1.9106 plus 2 pi n. And then that's going to be equal to pi over 8 times x minus 2. After that, after I have substituted this entire expression for inverse cosine of negative 1/3, this assures me that I'm going to get all possible solutions, not just the one that my calculator gives me and then have trouble with the other ones, because I have to take all of this and solve for x using the entire expression. So the next thing I'm going to do is figure out, working from the outside in again, I want to deal with the pi over 8. So I could multiply both sides by 8 and then divide both sides by pi, which would be fine. And if that's more comfortable for you, feel free to do it in 2 steps. But you can also do it all in 1 step by multiplying both sides by 8 over pi, because the pi's and the 8's both divide to give you 1. And so that all is just 1 times x minus 2. And then over here, 8 over pi has to be multiplied times this entire thing. So when you're in brackets here like this is like a grouping symbol, like parentheses. So 8 over pi is going to be multiplied times both of these numbers, but it's also going to be multiplied times 2 pi n. So everything gets multiplied by 8 over pi. So on my calculator, I'm going to go back and use my grouping symbols again, and I'm going to go up and grab my inverse cosine of negative 1/3, and then also negative of that, and put them both in the parentheses here. And so I have my first two values, which are the positive and negative 1.91063. And then I'm going to multiply this whole thing by 8 over pi. Okay, so I multiply by 8 over pi. Notice I get 4.8, positive and negative 4.865. Still nothing that I'm seeing on my graph as solutions, but that's okay, we're not done yet. So let's put that next step down. So I have negative 4.8654. I think I'll just go ahead and round it to 8654. And negative 4. Oh, sorry, the first one's positive. Positive 4.8654 and negative 4.8654. Now, when I multiply 8 over pi times 2 pi n, so I'm going to kind of go over here and do this in a little box over here. 8 over pi times 2 pi n. Notice the pi's cancel, and I end up with 16n. Why? That's the period of this function is 16. I already determined that up here, that the period is 16. So that's exactly what I want to have happen. So this is telling me I'm going to add the period to my original solutions. Now you might say, well, these still aren't solutions I see on the graph, negative and positive 4.8, but we haven't dealt with the minus 2 yet. So if I add 2 to both sides, this is going to shift the solutions to the ones I see on the graph. When I add 2, notice I'm not going to be adding 2 to the 16n, because 16n plus 2, those aren't like terms, so you can't add to 2, and when you add, it doesn't distribute anyway. You're just adding to these two numbers. So when we add, we get 6.8654 plus 16n, and negative 2.8654 plus 16n equals x. Now I want you to notice on your graph that two of the solutions were 6.87 and negative 2.87. Those are the two solutions that you see here. They've just been rounded. So we have found the first two solutions, the 6.87 and the negative 2.87. Now we need to find additional solutions. So what are we going to do? Add the period. Okay, the period is 16. So when n equals 0, these are the two solutions that we found when we don't add any period yet. Then we're going to take the first two solutions and we're going to add 16. So when n equals 1, that means we're going to add 16. Well, when we add 16 to 6.8654, we get 22.8654, which is clearly too big. And you know what, I think I'm going to go to my calculator here and I do a little adding here. First I'm going to add 2 to both of these, and that'll get me to my solutions. And then I'm going to add 16 to both of these. That gives me 22.8654 and 13.1346. Well, 13.13 is one of the solutions that you see on the graph. So 13.13, and I dropped my paper just a second. 13.1356, I think it was. If not, it was probably something pretty close to that. I guess I'll double check just to be sure. 1346. Okay, so it rounds to 135. 1346. Okay. So if we go back up and look, there's my 13.13, so that's another solution. The others, the 22 is too big because I only want solutions between negative 20 and 20, so this one's too big. Now the other solutions I'm looking for are two solutions to the left of my original 2. So I found these 3 so far, and now I need to subtract 16 from my original solution. So if I make n equals -1, that would be minus 16. So I'm going to go back to my calculator. I'm going to go back up to grab these two solutions and then subtract 16 from both of those. And I get negative 9.1346, negative 18, both of which are in between my bounds of negative 20 to 20, so I can use those two solutions. And I think I've got these negative 19.1346 and negative 18.8654. And if you look at the solutions up here, there's my negative 19.13 and my negative 18.87, which was rounded up. And there are my 5 solutions. So this is the process by which you are going to solve a more involved equation. The thing that you have to be very careful of is when to stop and write the general solution. When you take the inverse cosine, so I might write this up here. When you first use inverse cosine, stop and write the general solution. Okay, so this is replacing the inverse cosine that's in here. And then finish solving. When you finish solving this way, you'll get the correct first and second solutions and the correct period. If you don't follow this order, you may get one of the correct solutions, you may get half of the correct solutions and miss the other half. Notice that these two numbers do not turn out to be negatives of each other, opposites of each other, because of the lack of symmetry in the graph. Now, a couple final questions. Could you solve example 3 when y equals negative 2? So let's put negative 2 in here. See if I can do this kind of. Negative 2 equals, let's see, was it 2 plus 3 cosine pi over 8 times x minus 2. Obviously, I can't fit all this thing in here, but if I were to subtract 2 from both sides, which would be negative 4, and divide by 3, I would end up with negative 4/3 is equal to cosine pi over 8 times x minus 2. And then I would end up taking inverse cosine of negative 4/3 is equal to pi over 8 times x minus 2. You would find if you tried to solve inverse or tried to do the general solution at this point, you would get an error message. Recall that negative 4/3 is not in the domain of inverse cosine. Inverse cosine has a domain from negative 1 to 1. This is less than negative 1. It's too big of a number. This is a case where the adjacent side would be bigger than the hypotenuse if you were doing thinking of SOHCAHTOA here. For the same reason, this second one, could you solve cosine of x equals 3/2? That would be x equals inverse cosine of 3/2. Both of these numbers here, this number here and this number here, are not in the domain of inverse cosine, which is negative 1 to 1. So if that happens, if you're solving an equation and you get this, the first thing I would do would be to double check your arithmetic. And if you've double checked your arithmetic and you're still getting this, then it means that the equation is not solvable. In the second one, there wasn't really much arithmetic to check. The first one, I did the arithmetic correctly, so why isn't it solvable? Well, if you look at the original problem here, notice that the lowest that this equation goes is negative 1. There are no y values at negative 2, which means there aren't any x values that could give you a y value of negative 2 in this particular equation. It's not possible. So that's why I got something that gave me an error message. So be careful as you solve. Watch out for that. And hopefully by following this along, you'll kind of know what you're doing. I'm going to give you one more look at this, and just to show you kind of what I did. I'm going to copy some of this into the notes, so I'll print out the notes to go with this, and you can see the calculator instructions that go with what I did.